In this last video for Module 16, we're talking about cross sections and if we rotate a 2D figure and how it creates a 3D figure and what that 3D figure is going to be. So a cross section, to begin with, is when we take a 3D figure and we are basically slicing it somewhere through that figure to figure out what shape is created if we slice off a piece. So in number 1, we can see that the shape that's created, if this is parallel to our base, the shape that's created is a circle. It is parallel to the base, and so that means it's the exact same size as the base of the circle. In number 2 now, for this cone, if we go straight down the center, it looks from the vertex straight through the bottom of our base, we have a triangle. The base, or the width of our triangle at the bottom, should be the diameter of that circle. Now for number 3, we have a sphere to begin with, and our slice is not going through the center of the sphere, so that means that we still have a circle for what it's created, but the circle has a different size radius than the sphere because it's going to be not through the center, so it's not going to be the same distance all the way across. For this very last one, for number 4, you can see that we have a regular polygon. It's really a hexagon. So when we connect, it looks like the vertices together. This is just creating a rectangle. And in this rectangle, it looks like the width is just the height of our prism, and the length would be the diameter of our prism. The second thing we're talking about in this video and in this section is if we start with a 2D figure and we rotate it around a vertical line or around some type of axis, so here's a vertical line, that is going to create a 3D figure. And so we need to figure out what that 3D figure is going to be. So with this right triangle, if we rotate this around, it's going to create, like this point A is still going to stay there, so this bottom part is going to create a circle around the bottom. And like I said, point A is still going to be up there at the top. So point A stays there, point C rotates all the way around, and point B is really the center of this circular motion. And that means that this creates a cone. That also means that BA is the height of the cone. Moving on to number 6, I want you to try this one yourself. So if here's my line going right down the center, and we take all of these coordinates and we just spin it around, think of like a penny. If you spin it on the table, what shape does it create? You should have chosen that it creates a sphere. So if you think of spinning a penny on the desktop, it's going to make a sphere. And here's my really badly drawn sphere. So my radius is still the same radius of this original figure. On this last one, this is also a very common one you're going to see. If you think of spinning a piece of paper around one of these sides, so if we're going to take this, and we're going to take all of these coordinates and just turn this around in a circle, it will make a curve again. So this top point is going to make a curve all the way around, but the bottom point will also make a curve all the way around. And then we still have the connecting line connecting them together, so this is going to make a cylinder. So the height of my rectangle is still the height of my cylinder.